So I'm delighted to be joined by Tony McKee today. He's the CEO of a company called Memsstar. Welcome, Tony. Thank you for coming in. So you've got a fairly unique little company based up there in Livingston in Scotland. Tell us a bit about it.
Yeah, so Memsstar, we're 20 years old this year in August. We were founded in 2003. And initially we started the company providing service support for semiconductor industry, mainly for European semiconductor industry. And then after a while we started looking at MEMS processes to see where we could add our knowledge and experience in modernising MEMS processes for manufacturing. And that's when we looked at release applications. So as a company, our background has always been etch and deposition.
Right.
So when we looked at MEMS process flow, we looked at the etch and deposition side. And at that time, a lot of the release processes were still done using wet chemistry.
Yes. And
we looked and said, well, okay, how can we improve upon that, develop that for better performance, better process capability? And basically that's what we started doing.
So you then developed a range of applications around using vapor phase to do the etch.
Yeah, I mean, if you look at, so we focus mainly on surface micromachine MEMS. So if you look at the very last step of creating that MEMS device, it's what's called a release process. Yeah. And that's where you're removing an anchor material from the structure to leave a fully freestanding three-dimensional device. Yeah. Now, if you look at the release schemes over the years, the two predominant schemes are silicon and silicon dioxide.
Yes.
Okay, so those are the most common anchor materials, if you like. And we looked at that and said, okay, well, let's look at focusing on those two. So we have a xenodifluoride system, or a xenodifluoride-based system for etching silicon, and an HF-based system for etching oxide.
I see. Okay, and and I believe one of the issues as well is with other systems is that once they're exposed to these vapor phase systems, everything's exposed, and there are certain types of substrates and materials that can't be handled in other systems that can be handled safely in yours.
Yeah, that's absolutely correct. I mean, if you look at, as an example, take oxide etching. Prior to vapor phase, this was done using HF acid. Yeah. And as we know, HF acid is quite an aggressive etchant, and will etch a whole host of other materials. An example, aluminum. So that excluded certain materials from being involved in a MEMS design and a MEMS integration. What we looked at is processing techniques that allowed the use of materials that were excluded previously, aluminum being one of them. Because really what we've been trying to do is allow MEMS to be built the way they were designed, without necessarily having without having to restrict your design because of inadequacies in processing.
Right.
And a lot of that's based around selectivities to other material. Because as you rightly say, when you're etching the oxide, everything else that's on that wafer is exposed to the etchant. Yeah. So it's a case of working on techniques that allow everything else to survive the etch.
Right, okay. So, and I'm right in saying that your systems work on anything up to sort of 200 millimeter, 8-inch wafers or below?
Yeah, that's correct. So in terms of the manufacturing systems, it's any wafer size up to 200 millimeter. We also have an alpha system, which is an R&D system designed for universities. So it's a smaller manual load type system. But everything we do so far is up to 200 millimeter. Okay.
So, how big is the market for your area of
It's actually a relatively small market. So if you look at MEMS, there's two. So broad brush, you've got two ways of making MEMS. You've got bulk micromachined and you've got surface micromachined. So bulk micromachined is the majority of MEMS, and that would involve techniques like deep silicon etching, for example. So the deep silicon etcher was one of the first pieces of etch equipment designed specifically for MEMS applications.
Yeah.
So then you have the surface micro machine, and that's the area that we're focusing on, is in the surface. So that is a smaller subset of the MEMS market.
The MEMS market.
Yeah.
Right. Right.
But it's a growing market because MEMS are evolving. They're getting they're getting, what's the best word? I mean, they're getting smaller, they're getting a lot more challenging. Mm-hmm. What we're seeing in the MEMS is a greater use of different materials that not necessarily used in semiconductors.
Yep.
So more use of the periodic table compared to semiconductor industry. So they've got their whole unique challenges, and also the big challenge is it's a three-dimensional process.
Yes.
When you're looking at semiconductor process and etching, it's two-dimensional.
Mm-hmm.
As people ask me, what's your etch rate? And I say, okay, well, do you want the etch rate down or you want the etch rate across?
Right.
Because it is a fully three-dimensional process.
Yeah. Interesting. So, as I said earlier, you're based in Livingston. You've got a footprint throughout Asia using reps and
Yes.
distributors, and likewise over here in the United States.
Yes.
How big are you seeing an increase in demand for your processes and products as a result of the recent changes in US Chips Act and the European Chips Act, this type of thing?
No, absolutely. So if you look at China, China is growing, at a fast pace in anything to do with wafer manufacturing, because they are looking to be self-sufficient and less reliant on the West.
Yes.
For their chips, and so there is a lot of activity in China just now for whatever it is, whether it's semis, whether it's MEMS, whatever, anything on silicon. There is a lot of interest in China at the moment. Right.
But do you see that growing over here as they also try to become independent?
Yeah, no, I think it is. I think the advantage that we have in the Western world is the amount of R&D effort that we've had, because we've had that for a long, long time.
Yes.
MEMS aren't new. Mm-hmm. They've been around probably as long as the transistor.
Yep.
And if you look at, Europe and the US, there's decades worth of R&D and development work actually being invested in the West. And so again, that experience and that knowledge doesn't come overnight.
Yes.
So for me, that what I see in China is the start of it. And if it takes the same evolution as has in Europe and the US, then it will become a substantial market.
Substantial market for you. Yeah. Excellent. Yeah. Well, it's interesting to sort of learn about the technologies you're doing, Tony. So I want to thank you for coming in and telling us about it today.
No, thank you very much for the opportunity. It was my pleasure, and it was good to see you.